Help. Oh, it's glitching. Hi, my name is Jillian.
My name is Riley.
I'm Maddie, and this is our drinking water challenges for chemistry.
So, what is water? Water is overall a chemical compound with a molecular formula H2O. It's composed of two hydrogen atoms bonded to one oxygen atom. It exists in three different states, which contain solid, liquid, and gas, as you can see in the pictures.
Why do we need water? Water is essential for life. Water is a fundamental component for all living organisms. Hydration. Keeping our bodies hydrated is critical for temperature regulation, circulation, and maintaining bodily functions. Cognitive function. High levels of hydration are strongly connected to concentration and alertness.
What is the problem? The world is facing a water shortage. 26% of the population, which is about 2 billion people all across the world, do not have access to safe drinking water. Some people have to walk miles to access water that most of the time is not safe or properly sanitized. As you can see in these photos, some people can walk down the street to Target and have access to different brands of all safe water, and you would never have to worry about what kind of water you're drinking or where it's coming from, and you would know you wouldn't get sick from it. But in other countries, people unfortunately have to drink very unhealthy water and unsafe that can cause sicknesses.
Climate change. Climate change has a significant impact on the water supply shortage. Precipitation equals water. If the rain does not fall, no water is obviously being produced. The sea level rises. The rise of the sea levels can cause salt water to intrude into freshwater sources, compromising the quality of drinking water. Droughts. Droughts are intense and prolonged droughts can cause an in-demand for water, causing water scarcity in some areas of the world. So as you can see in our image, obviously the water is dirty and there is a drought occurring.
Overuse of water / wasting water, leaking faucets and hoses, running tap water, for example, like leaving on the sink while you brush your teeth, or washing your hands or doing the dishes. Prolonged showers or baths, running appliances when not full, for example, not doing full loads of laundry or dishes. Excess flushing, toddlers or children tend to flush toilets frequently. People using the toilet as a trash can.
Contamination. So the pollution of drinking sources. Contamination of rivers, lakes, and groundwater with pollutants such as industrial chemicals, heavy metals, or agricultural runoff can make for unsafe water for drinking. So this can be oil leaks from machinery, smoke from the air, car exhaust, oil spills in the river. Oil spills occur in rivers, oceans, and lakes, which can cause contaminations in water, causing unsafe drinking water. Think about all the things that go into cars and other equipment. You would not want some of that stuff produced into your water, making unsafe drinking water. And more than 3,000 children die a day due to contaminated water.
What makes drinking water safe? Protection from unsafe contamination. Water treatment. Water treatment helps neutralize water and get rid of bacteria. This can be done with chlorine, UV, etc. Monitoring and testing. A variety of tests can be done to make sure water is safe to drink, swim in, serve, etc.
Treating our drinking water. Water treatment plants source water from aquifers or lakes. The initial process is passing water through a screen to remove objects such as weeds, sticks, plastic bottles, and more. Chemicals are also added to the treatment process, such as calcium hydroxide and aluminum sulfate. Yeah, why is that moving? Oh, did I?
Some of the history of water treatment. So as you can see, in the year column, we have the 1900s to the 2000s, and you can see that the rate of 1,000, 40 states have health departments, and as it decreases, the first continuous multi-additional use of chlorine water in the United States. So chlorine is more common than we think. Obviously, it's in pools, but it is also used to clean water for our safety. But then all of a sudden we see a rise, and this is when the influenza pandemic comes. And studies have shown that the influenza pandemic has been, or a cause of it has been unsafe drinking water, causing contamination of germs. And this is the last human to human around the 1930s of the plague. And in the 1940s, it's the first use of penicillin, and then the vaccines become introduced in the passage of the Vaccination Assistance Act. So you can see that the water treatment goes down, and the rates decrease as well as we go from year to year.
Hallucinating agents. Aluminum sulfate and calcium hydroxide act as hallucinating agents. This forms a gel of aluminum hydroxide which collects dirt and clay products. Chlorine and contaminating compounds such as chlorine gas and calcium hypochlorite prevent bacterial contamination. Example, John Snow's chloral study.
What do our particles look like in water? Before they're in water, they have a negative charge. And then while they're they literally don't.
Coagulant.
While they're coagulant, they are at a neutral charge, and while they're fluctuant, they're settled agglomerates.
Using UV disinfection. So UV disinfection is a non-chemical method used to treat water. It involves the use of ultraviolet light to inactivate microorganisms in water. UVC light with a wavelength between 200 to 280 nanometers is the most effective for disinfection. This range is absorbed by the DNA and RNA of microorganisms. As you can see in the image below, the water goes through the left side of the UV disinfectant, and the UV light treats the water that's in the tube or wherever it's stored, and then the water comes out treated and safe. This technology is growing, and so more UV disinfection will be common in other workplaces, schools, buildings, etc.
Sewage water. Sewage water compromises wastewater from homes, businesses, and industries, containing contaminants like microorganisms, chemicals, and solids. Oh gosh. Screening removes large debris, followed by primary sedimentation to prepare solids. Secondary treatment utilizes microorganisms to break down organic pollutants. Tertiary treatment and disinfection. Treatment water of effluent is released into water bodies or reused for non-portable purposes. Stringent regulations ensure compliance with water quality standards. So as you can see, here's that nasty water. Refilling this looks like a canal.
Where are the water shortages happening? The top 5 places that water shortages happen are in Bahrain, Cyprus, Kuwait, Lebanon, and Oman. So all the red areas are the highest, contain the highest contaminants and the water shortages.
And the lighter colors show where there isn't as bad water contamination shortages. My apologies. Technological innovations. So, smart water meters are devices that measure and communicate water usage from consumer to provider to facilitate water management and proper billing. Ozonation is the use of ozone to treat water, and there are leak detection innovations that detect leaks in water places and will alert the people to get it fixed, therefore wasting less water. And there are also drones for water management in larger areas, and there are also blockchains for water transaction. As you can see in the image, there's the contact tank. This is of the ozone treatment, and it goes through the mixing pump, and it heads out through a filter, and yeah, it safens drinking water. This one is definitely not as common as the UV disinfection, but it is definitely growing.
How do we use water? Water usage in the U.S. is extensive, 322 billion gallons withdrawn daily, 14% saltwater, and 86% of that is freshwater sources. The primary uses of water. This consists of electricity production, crop irrigation, and residential commercial use. The direct purposes are bathing, drinking, and washing. The indirect purposes are agriculture, industry, and electricity.
Indoor water usage. Where does water go inside? Average indoor household water use. 20% of that is from the toilet. 19% of that is from the washer. 19% of that is from the shower. And 19% of that is also from faucets. 14% is from leaks. 5% is from baths. 1% is from dishwasher, and 3% is just miscellaneous.
Water footprints. What is a water footprint? It is an environmental indicator that measures the volume of fresh water. Water footprints for meat and grains, and there are water footprints for various other products. As you can see in the tables below, it shows the global average of the water footprints in liters and how it varies per product.
Research in water conservation. The development of intelligent technologies and sensor networks for on-the-spot water usage monitoring is the main focus of research. Using Internet of Things, IoT, devices to improve water distribution and quickly identify leaks. Systems for smart water management. Cutting-edge water treatment technologies. Investigation of cutting-edge techniques for treating water, such as membrane filtration and nanotechnology, studies on energy, and sustainably efficient methods of recycling and purifying water supplies.
How to help those without clean or safe water. To help, you can donate to water organizations, i.e. Clean Water Organization, One Drop Foundation, the Water Project. You can volunteer for water projects. You can purchase water-saving products like aerators, shower head sensors, and more. To support hygiene and cleanliness education programs.
That was the wrap up of our drinking water challenges. We hope